For this section, we are going to learn about polar coordinates. And before you learn about the rectangular coordinate system, and we will use x and y to represent the coordinate in rectangular coordinate system. And today we will learn about another coordinate system which is called as the polar coordinate system. Then let's look at some basic idea about the polar coordinate plane. And in the plane, we are going to learn two elements. And first is called as the pole, P-O-L-E, pole. And that is the center point in polar coordinate plane. And in the polar coordinate plane, you can see that we will draw in this way, other than the pole, and here we mark it as O. This is not the 0, we mark it as O. It is called as the pole. And next is the polar axis, which is similar to the x-axis in rectangular coordinate system. But we only have one direction, just like the positive direction in rectangular coordinate system. And for this polar axis, we will mark it in positive only, 1, 2, 3, 4, 5, 6, and so on. And you can see that for the polar coordinate plane, we always mark like many circles here. And how to represent a polar coordinate? Then we can look at this diagram. For example, if we consider a point P in the plane as shown, and then you can see that for the polar coordinate, we also need to compare it with two coordinates, but not x and y. And now we are going to use r and theta. And what is the meaning of r? R, that is the radius factor. Radius factor, that is the length of joining O and P. That means the length of OP. And it seems like a radius of a circle. For example, if here we have a circle, I may draw a circle like this, and O is the center. And then you can see that OP is the radius of this circle, and that's why we call it as the radius factor. And then we can check what is the value of R by reading on the polar axis. And for the polar axis here, for example, I may mark the polar axis here. For example, if for the polar axis here, if, okay, I just give an example. If here is equal to 5, then you can see that the radius of this circle, which is equal to 5. And that's why the length of OP, because OP is also equal to the radius of this circle, and that's why R is also equal to 5. And next is about the other element, that is the theta. And theta, we call it as the polar angle. And for this polar angle, we always use the measurement from anti-clockwise, and from which part? That is from the polar axis, OX, and then measure it in the anti-clockwise direction, that means this direction. Then to measure the size of the angle, that is theta. And then just read the size of theta from the polar coordinate plane. And then let's look at some example later. So we can see that here you got the idea about how to represent a polar coordinate by r and theta. R is the radius factor, and theta, that is the polar angle. And let's look at some examples. And for this example 12, and you can see that the figure below shows a polar coordinate plane. And for this plane, you are asked to write down, just write down, no need to explain any more about that. Just write down, and then the coordinates of P, Q, and R. First of all, we may look at the point P. Remember, we have to represent the polar coordinates by R and theta. Then let's look at the R first. That means the radius vector. And for R, you can see that for R, we can read in this way. That means the length of OP. Okay, the length of OP. And then the length of OP, I can read here from the X. Okay, X, that means the polar axis. That is 5. That's why R equals to 5. And next, let's look at the polar angle. And for the polar angle, you can read from here 20 degrees. Okay, 20 degrees. That's why the polar angle theta, which is equals to, I may use another color. And that is 20 degrees. And that's why the polar coordinates of P, that is 520 degrees. That's all. Then you can write down the polar coordinates of P. And so on, I think you can try to finish to write down the polar coordinates of Q and R easily. Then you may try it.